Hi, today we're going to talk about multiplying a polynomial with a monomial. Okay, if you remember, a monomial is just one term, and we're going to multiply it with a polynomial which might have 2 or 3 terms inside of it. Okay, and basically what this is going to boil down to, it's just simply the distributive property. We're going to take this term outside, whatever it is, and we're going to distribute it to each thing on the inside. So shouldn't be too bad today, I hope. Okay, here's an example of one. Okay, I have a monomial outside multiplied by a polynomial, a trinomial. Okay, and if I take this monomial outside and I distribute it, I'm going to get negative 21. X squared times x squared is x to the 4th, and the way I'm getting the 4 is we're adding the exponents. Negative 3 times negative x is positive 3x to the 3rd, and remember there's a little 1 on the x, so 2 plus 1 is the 3rd power. And then I take the negative 3 times 4, and it's going to turn into negative 4x squared. Okay? And if I look close at my answer here, there's no more like terms. That's as far as we go. Okay? And when there's just one letter in the expression, one variable, we typically like to write it from biggest power to smallest power, and that's what we call standard form. Okay? There's one. How about another one? Can you take a second and try this one by yourself? Push pause, give it a whirl, and then push unpause. Okay? All right, welcome back. Let's see how you did. If I distribute each of these, negative 6 times 3 is negative 18, and I'm going to add my exponents to get d to the 7th. Negative 6 times negative 2 is positive 12, d to the 6th, 3 plus 3. Negative 6 times negative d is positive 6d to the 4th. And negative 6 times negative 9 is negative 54, d to the 3rd. Okay? And again, I only have one letter in the expression, and it goes from biggest power to smallest power. No like terms. There's our answer. Okay, very nice, good. Okay, well, can we extend this to a little bit bigger expressions? Maybe some that have more than one polynomial that's being multiplied. Okay, we certainly can. Let's give this a try once. Okay, I see 2 expressions. I'm going to take this first one and distribute it through. And if I do that, I get negative 8p cubed. 2 times 5 is 10p squared. Okay? Now in the second one, before I distribute, I need to look at that 5. I need to look at what kind of a 5 is that. And if you look closely, that's a negative 5. Okay? And you could do a change if you wanted to, but I'm going to simply keep it negative. So negative 5 times 2 is going to be negative 10p squared. And negative 5 times 20 is negative 100, not 200. Is negative 100. Okay? Now this one only has one letter, but if you look closely in the middle here, it has some like terms. Okay? 10p squared minus 10p squared, they cancel out, they go away. And the only thing I have left is negative 8p cubed minus 100. Okay, very nice. So yeah, so it doesn't make any difference how many different polynomials we're going to multiply and add and subtract and things. But if there's a minus sign in there, remember, that makes that 5 become a negative 5, and you can certainly switch it to a change. Okay? Let's try this one on the right here together. It looks a little bit bigger and fancier. Let's give this a whirl. I'm going to take the 15 and distribute it through to my first set of parentheses. And again, if I multiply the big numbers, 15 times 10 is 150. And it looks like I have y cubed, and then t to the 1st and t to the 5th gives me t to the 6th. There's 6 of them. Then if I take 15 times 5, that's positive 75. It has y squared, t squared. 1 and 1 gives me 2 t's. Okay, here again I have a negative 2 back here, so I'm going to get negative 2y squared, t squared. And back here I'm going to get negative 8y cubed. Y times y is y cubed. Now here's one that has a couple different variables in it. Okay, when we have more than one variable in it, we're not going to be too terribly concerned about writing it in standard form. But let's see if there are any terms up there that are like terms, that have exactly the same letters and exactly the same exponents. And if you look carefully, right here in the middle, I think both of those two things have a y squared t squared, and they can be combined. 75 minus 2 is 73, y squared t squared. But again, they have to have exactly the same letters and exactly the same exponents on them. Okay? This one just comes along for the ride. And then negative 8y cubed. Okay? And there's my grand finale answer right there. And again, they don't have to be in a specific order. When you check your answer in the back of the book, they may be in a different order, which is fine, but just make sure that each term has the correct sign on it. Okay, very nice. Okay, so again, it's just the distributive property. Okay, the last thing they're going to have us do in this section is they're going to have us solve some equations. Okay, and we're going to practice a couple here. 12 plus b minus 7 is 2b plus b times, 2b plus b times negative 4 plus b. Okay? So way back at the beginning of the semester here in the class, we solved equations that had variables on both sides of it. Okay, this is just a little bit fancier version of it. And what we did at that time, okay, is we kind of used this equal sign and kind of used that to split the equation in half. Okay? And what I'm going to do is I'm going to simplify the left-hand side all by itself, the right-hand side all by itself, and then go from there. So let's start on the left. If I start over here and I distribute my b, I get 12b plus b squared, and then my minus 7. Okay? There are no like terms over there. That's as far as I can go. But on the right-hand side over here, I can distribute this through to this parenthesis, and I get minus 4b plus b squared. Okay? On this side, though, I do have a couple like terms. Those can be combined. 2 minus 4 is negative 2b plus b squared equals 12b plus b squared. B squared minus 7. Okay? All right, so I've simplified each side individually all by itself. Okay, now what do we do? Well, if you remember, the ultimate goal here is to get all the b's, or b, all by itself on one side of the equation. And a lot of you guys just always like to move things to the left, so maybe I'll go with that route. What if I moved this b over here? Okay, I can combine it with that one, and because it's a negative 2b here, I'm going to add it to the other side to get 14b. Now it's gone. Okay? B squared. What if I move this b squared over to this one? I would subtract b squared, and they actually end up disappearing. Okay? And the only thing I have left is minus 7. And when everything is gone on this side, it's all gone. It's equal to 0. Okay, that's looking a little bit more familiar. Again, let's see if we can just get b by itself. Well, here's the b. I don't want the 7 over there, and because it's a negative 7, I'm going to add it. So 14b equals 7, and then I'm going to divide by 14. Okay? Now we get a fraction here. Always, 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 whenever we have fractions, we always need to reduce them. And if you divide those, okay, I can divide them both by 7. It turns into a 1 and a 2. So I get b is equal to 1/2. Okay? And one thing that I can always do to check my answer is we could take this 1/2 and we could plug it in up there everywhere we see a b. Okay, and you can do that all in your calculator. Just for time's sake here, it would check this side would be equal to the other side. So it's just like when we did algebra a long time ago, you can check your answers fairly simply, or fairly easily. Okay, oops. All right, I got another one here I'd like to try real quick. Okay, how about this one? Oops. Okay, what if I had n times n plus 3 minus n times n minus 4 equals 9n minus 16. Let's try one of these ones. Okay, same thing. Again, if I find that equal sign, and I let that split the problem in half for me. Okay, I'm going to simplify the left. If I distribute through the first set of parentheses, I get n squared plus 3n. Okay, now this one, be careful. What kind of an n is that? It's a negative n. So when I distribute negative n, I'm going to get minus n squared. But a negative and a negative make positive 4n equals 9n minus 16. I can't do anything on this side. Well, if I look carefully at the left, do I have anything that I can combine? Any like terms? Well, n squared and n squared are like terms, but n squared minus n squared, they cancel out again. Okay? I think these two guys are like terms also. 3n plus 4n is 7n equals 9n minus 16. Okay? Well, what if I keep going? What if I do what we did before and we move our n's way to the left? I would subtract 9n, because that's a positive. I get negative 2n equals negative 16. Okay, 7 minus 9 is negative 2, and then if I divide by negative 2, they go away. And right here, negative 16 divided by negative 2 is positive 8. So that time I get a nice answer. Okay? Yeah, it's just using the distributive property, combining like terms, getting all the n's on one side, and we solve from there. Okay? Oops. Okay, here's one great big last problem. I think you're going to see one like this on your assignment maybe. Now it looks kind of big and scary, just because there's so much stuff there. But let's keep it simple. Okay, let's do as much as I can on the left-hand side, all by itself first. Well, I'm going to have to do a little distributing. I get 10a squared minus 2a. Here I get 6a squared plus 18a plus 8. Okay. If I combine some like terms, I can combine my a squareds. 10a squared and 6a squared is 16a squared. I can combine my a's. Negative 2 plus 18 is 16a plus 8. Okay, and there's that one. And that's as much as I can do on the left. Let's do the same thing here on the right. I'm going to get 4a squared plus a plus 12a squared minus 8a. 2 times 4 is 8 plus 50. Okay, it looks like I have a couple a squareds that I can combine again. 4a squared and 12a squared is 16a squared, so they're gone. The a's I can combine. 1a minus 8a is negative 7a, and then plus 50. Okay, so we're starting out big, we're getting it smaller, we're breaking it down, but that's as much as I can do on that side. Well, now let's get all our a's on the same side, and let's go with the theme here. Let's go left. What if I take these 16 and I move it over here and I subtract 16a squared? Well, they cancel out again, they're gone. Okay. If I take this 7 and I move it over to the other side, I'm going to add 7a. And 16 plus 7 is 23a. Okay? And at the same time, if I only want a's over here, I don't want this 8. So I'm going to subtract the 8 to the other side. And 50 minus 8 is 42. Okay? And if I divide by 23, I think I get 42 23rds. Again, I get a fraction, not the prettiest looking thing. Okay, but there we have it. Okay, so nothing to be scared about. Okay, just take your time, be careful of your signs, be careful of your multiplication, and then moving things back and forth. Okay, all right, thanks for tuning in.